circuit in OrCAD Capture. We're then going to make a netlist. We're going to take it into PCB Editor and we're going to create the board. So we'll try and do the whole flow in this video. So we'll start off. What we'll do is I'm just going to do a close. We'll do a new project. So inside OrCAD Capture, we'll start OrCAD Capture with the start page or from File and New. We're literally just going to click on New Project. We'll give it a name. So I'm going to call this My Design 1, and I'm going to give it a folder, My Design 1, so everything keeps together. That then creates the blank project area. So using OrCAD Capture, we can use Place Part, and then what we need to do is we need to add all the libraries. So let's just clear out the libraries for now, and we'll just select all of these and empty them out, so you can see how the libraries get added. So you start off with the design cache, which is effectively a copy of any parts for this design itself, but we'll start off, we'll do click on the new. Now by default there is some default cadence libraries that are provided. So if we look under the installation directory, so C:cadence SPB172 tools capture library folder, you'll see there's some OLB files, and these are some of the default libraries that Cadence give you to start off with. So I'm going to add the amplifier one. I'm also going to add the connector one and the discrete one. And that should be it. So I've now got effectively a group of libraries that I can add here and look for parts. So we'll start off with the amplifier, and if I know what the amplifier is called, I can actually start to type here, and then it will use a filter. And the part that I specifically want is an LMC6681. So up here, LMC6681. You can see the filter list starts to work. It finds the part. And there's two examples of this schematic part. I'm just going to pick this one, /SO, because it's got an SO, or it's based on an SOIC footprint. Add the part down, and that places the part for me. I'm then going to go to the connectors, and I want a header, so we'll just type header, and what I want is a header 6, so we can either do a type space 6, and that gives me a 6-way header. And in this example, I'm just going to mirror horizontally. And I'm also going to connect this to, in fact we won't connect this yet because it's mirror horizontally. Let's just put this down. We then want some discrete parts, so we'll look at the discrete library. I want a capacitor. We'll rotate this round. It's obviously going to be connected to the VCC pin, so we'll put this about here. Here we want an R. So I'm basically going to have one on the positive, one on the negative, and you can just drop the pin-to-pin connection to actually make connectivity here. And then once the resistors are placed, you can literally just drag them apart. So I can take it all the way across, connect it to pin 4, and I've made connectivity there. So you can just drag resistors around to make the connectivity, which makes it a little bit quicker than actually drawing the wires, which can be really helpful. Then I want some power and ground, so we'll have a VCC symbol. I'm going to use the VCC bar, and I'm going to name this VCC. And I want effectively one there, and I also want one on pin 1. And again, just drag the symbol to make the connectivity. And then I want another one of these, so we'll do a Control C, Control V, copy paste. Put it down and then rotate it round, and I'm just going to rename this to be -5 volts. And again, I want one on pin 5, and we'll do a copy paste on pin 4, and you can just drag these around where you want them. And then we'll get a ground symbol, click OK, put the ground symbol down. Now by default the ground symbol from the default library doesn't actually display the name, so we can literally just double click the symbol, it launches the property editor. It may launch the property editor in this kind of view if you prefer that. I prefer this view, so you can just click the pivot button to change the display, and then we can click on name, right click, display, and then specify value only. And then if we close this window, we've now got a value on our symbol. Copy paste again, capacitor. Don't press the F1 key. If you do press the F1 key, what it will do is it'll open up the cadence help. So if you get any questions, you can obviously just press F1 to get the cadence help. It can be quite useful if you need it. Right, let's actually draw some connectivity, so I can use either the place wire, there's a corresponding icon over here, or I can also use the W key as a shortcut, and then I can literally just start to wire up the rest of the bits. So I want so now in my original circuit there was actually another resistor going between the input and the output. In this example I'm just going to leave it because we'll do that as like an ECO change on the design, so you can see kind of how that flow works as well. So what we'll do now is we'll do some net aliases, or wire some net. So I click on the net alias button, ABC. That can also be done from place net alias, or the N key. You get the pop-up, so I want in plus. Click OK, and then I can go and click on the net where I want to label it. If I need to make a change, if I hit the Control plus E, I get the pop-up window again, so I can then go and make a rename, change the text. We'll do a Control plus E again, and I want an out, so we'll click OK to that. And that's my kind of very basic circuit. Now I want to start making some edits to some of these, because these obviously come with some default values, so I want to put some resistor values. So we'll just make these 10Ks. Now you can do this before, you can do this in the library and actually have a library to save you doing these on the fly. In this example I'm literally just going to do this on the fly because it can be easier. So we'll do a 0.1 microfarad capacitor. That's good enough. So we'll then do, what we'll do is we'll save our design. Now what I need to do is start looking at PCB footprints for these parts. So I can literally just window select everything here, and then I can select over any part and do a right click, edit properties, and I get the property editor. And there's tabs along the bottom, so I might get schematic names, I might get flats, nets, pins, title blocks. I obviously want parts in this instance, and I want to start looking at PCB footprints. So I need to apply a PCB footprint name. So some people use the IPC standard, some people have directories of PCB footprints. If we go to the default cadence location, so if we go to effectively where your software is installed, so C:cadence 17.2, there's a share folder, PCB, PCB_lib, symbols. This is effectively a list of all the PCB footprints that Cadence give you just as a starting point. Some people won't use these, they'll want to make their own PCB footprints from, using things like OrCAD Library Builder or PCB libraries. You can access them from the web, from free resources like Ultra Librarian, Snap EDA, so lots and lots of places to get PCB footprints. In this example I'm just going to use some of the default ones. So what I will show you is there is actually a PDF document. So if we go to the web, let's just bring the web browser into the correct window. If we actually go to orcad.co.uk, you'll come to the Parallel Systems homepage, and if we scroll to the very bottom of this web page, there's a footer information, there's something called user guides. So we'll click on the user guides. So here you'll see some very useful PDFs for OrCAD Capture, OrCAD Capture CIS, PSpice, PCB Editor, how to do lots of things. These are very useful PDF links if you're trying to do some specific commands, and then there's obviously some licensing options down here as well. And if you actually look at applet number 69, list of PCB footprints supplied in OrCAD with Cadence PCB Editor, that will effectively launch this PDF document. So this PDF document has a picture and showing you every single name of the PCB footprints that are provided, so you can have a scroll and see which PCB footprints you want to use. So starting off with the resistors and capacitors, what I'm going to do is I'm literally just going to scroll down this list. I know there's an SMR 0805, and that's the one I want to use. So I'm just going to select that text. We'll do a Control C from the Windows Explorer window, go back to Capture. So for my resistors, I'm literally just going to drag select the resistors, do a Control V to paste the resistor values in. My capacitors is SMC 0805, so we'll just put that value in. So the connector, I need a 6-way pin header, and I want an SOIC 8 effectively for the PDF, and if we go down to, and they're basically SOGs. So I can start using a tool, SOG0508, and hit the return key. Find next in there is actually an SOIC8, so let's use this one in this example. So there's an SOIC8 as a default cadence PCB footprint, so we'll do a copy on that, and we'll go back to our IC and we'll paste that value in there. So all we need is actually just the PCB footprint name. You don't need to put any extension names in here, it's literally just the PCB footprint name. And then for the header, let's go back to the PDF, let's just cancel that. So we're looking for the block. So we've got a block com 156, so 1, 2, 3, 4, 5, 6, that's the one I want. So I can effectively just come in and select the text here. Back to the schematic, paste. So I've now got PCB footprints applied for all my parts. So we can save this and close. Obviously, if you're using something like an OrCAD Capture CIS flow, all these property information will actually be stored with the parts when you generate your libraries, so you wouldn't have to worry about doing this type of thing when you're doing the design. It can be done as part of the database operation. So that's effectively my schematic design. I'm just going to save it, and then we're going to go Tools and create a netlist. I'm just going to create the netlist, and what we'll do is we'll start off, so we're going to create the netlist in OrCAD Capture. It makes an Allegro directory, and it puts the netlist files in that directory, and then it starts and it will generate a PCB board here. We're going to use OrCAD, we'll click OK, and away it goes. We've actually got an error, which is good, so we can actually go through, but we'll just pick PCB Editor as a starting point, and effectively that launches the PCB Editor tool. So you can see I've obviously got a list of my place components, but let's find out what that warning was. So if we go to File and View Log, change this file of type to all, there's something called a netrev.list. You can see if I look under that directory, so I'm now looking at C working my design one. I've now got an Allegro folder, that's where my board file is. If I go up one level, that's where my design files are, so we'll go into the Allegro folder. There's something called a netrev.list. This is effectively the file that gets produced when you generate a netlist. So if we actually look at this and we come through down here, we've got some warnings. So we've got some mismatches effectively. Symbol SOIC has an extra pin 8 and an extra pin 1. So we've got a mismatch between the schematic symbol and the PCB footprint. If we actually go back to the schematic and look at the schematic part here, we've obviously got 2, 3, 4, 5, 6 and 7. We haven't got pin 1 and pin 8. So from a netlist point of view, we must make sure that we have the exact same number of pins in the schematic symbol that we have in the PCB footprint. So ideally we would redraw this schematic symbol so we have all 8 pins on it, and maybe show some NC pins, but in this example we can actually just add a property to this symbol. So if we double click the part, we can add a new property here. The property name is called NC, and then the value is the list of the pins that are not connects basically, so it's going to be 1, 8. So it's a comma separated list. So if you had lots and lots of NC pins, you could put all the comma separated list in here to sort it out. So we'll click OK to that. We'll then close that, and we can resave our schematic. And let's go back to PCB Editor. Let's just close this off. We're not going to save anything now. And then we'll go to Tools, Create Netlist. Leave all the defaults because they're all fine as I've got now. Click OK. I don't get any warnings this time, so when I click on, we're using OrCAD standard license for this example, it then launches PCB Editor, and there's a list of my components ready to place with no errors. We can actually open that view log again, so File, View Log, let's look at that netrev.list file, and you can see no errors or warnings. Okay, this is what you're really after when you netlist the design. So, first things first, let's go to Setup and Design Parameters. This is the settings for the PCB view we're going to look at. So I'm going to do things like go to the Design tab. I want to use millimeters for this design. I probably want to set my paper size up as well, my area, my working area. I'm going to use an A4 piece of paper here. If you look at the grid, obviously you can see if I change this to A2 and hit apply, you can obviously see this paper size will increase based on the settings that we put here. I just need an A4 piece of paper for this kind of working area. There's also, there are other settings here as well, so maybe I want to show plated holes and non-plated holes from a graphical point of view. I'll click apply and OK, and then effectively that's my default settings. Let's just turn the grid on for now, and we'll actually set the grid as well. So if we go to setup grids, I've obviously got an on-etch grid for placement and an etch grid for routing. So I'll set my non-etch grid to 0.5 and my etch grid to 0.1. And I can just use the tab key to kind of cycle through these different boxes and settings and stuff like that. I then also want to change the drawing origin. So obviously at the moment this is 0, 0, right in the bottom left hand corner of the screen. You can see this is my coordinate system down here. So what I want to do is I can go to setup, change origin, just give yourself a bit of working area, because I want this to be the bottom left hand corner of my board, of my design. So what I want to do now is I want to draw a board outline. So I can either use something like import MCAD and pick either DXF, IDF or IDX if I had a complex shape or something like that. In this example it's a simple rectangle, so I'm literally just going to go shape, rectangular, and then if I look in the options pane, so this options pane changes depending on the command that I'm in. I can either use the draw rectangles, but I want to pick the active class, so it's going to be a board geometry, something called design outline. And then I can either just left click and drag, or I can actually type the specific commands that I want. So I'm going to say X is 0 space 0, so it's X space 0 space 0, hit return, and that's the starting point. I then want my board size, and if you know what your board size is going to be, you can obviously type the values in. In this example, my design is going to be, I want 26 in the X, so 26 millimeters in the X, and I want 21 in the Y. Hit return, and then that draws my board outline that I can use, obviously. So that's the design outline that I need to do for my board size. So the next thing I want to do is I want to do things like placement areas, or I want to do root keepings and placement keepings, so I can DRC to the edge of the board. The simple way to do this is using shape Z copy, which is like an offset command. So I look at my options pane, I can set this to effectively root keeping, a keeping area. I want it 0.5 millimeter away from the edge of the board. And then I click on the design outline or the board outline. You can effectively then see this offset happens, and I then get my root keeping, and I also want a package keeping so I can stop components from overhanging the edge of the board as well. So we'll do that as well. That makes the two shapes that I need. We'll do a zoom center. So I'm ready to start kind of like, let's just save my board. Let's start looking at placing the component. So I can literally just left click on J1 here, and then that part is then attached to my mouse, and I can then come in and place J1 where I want it on the design. Another method effectively is if I go to place components manually, I get that same list, but it's now available in my box here, so I can look at where I want to place this part. Maybe I want to rotate the part round a bit, so I can just do a right click rotate. I can also do a right click mirror, which flips it to the back side of the PCB, and you can adjust where you want this part to go. If I needed to change the angle, I could come over here and set this to 33 degrees. So when I did a right click rotate now, you can see it will rotate at 33 degrees if that's kind of the placement that you normally want to do. In this example, I'm only going to use 90s. So we'll set that back to 90, and we'll rotate the part round, and let's just chuck it down there for now like that. Another method of placing parts is if I then hide this window, what I can do is I can get my schematic and my PCB up side by side. Look at my parts, so I can then start to pick on the resistors, single click the resistor and bring the parts into the design, single click the resistor, bring the part into the design. Let's get the capacitor, and that's all. Oh, I need the other resistor as well, so we'll get the other resistor as well. So that's all the parts in. If I now look at, we'll do a right click done, you'll see my placement list is empty, but I've also got something useful. So if we go to check and design status, you can see I've got no unplaced components. There's quite a useful report. I can click on these little coloured check boxes and it will show me effectively any reports that we've got. So now I've realised actually I need to go and add that resistor going from the input to the output. So what we'll do is we'll literally just save the board, and we'll close PCB editor down. If I go back to my schematic, what we'll do is we'll just do a Control C, Control V, because I want the PCB footprint and everything else to be the same, the value. I can drop the resistor down, we'll use W to wire it up, and we'll go between pin 6 and pin 2. We'll save the page, go to the design, and then we can go Tools, Create Netlist. Now obviously the important thing here is it's starting with a blank input board file. If I do this, it's going to overwrite any work that I've got. So what I need to do is effectively do a copy and a paste, which basically says from an ECO point of view, start with that design that I had and then overwrite it and make the same design name. You can, if you want, give it a different name so you start to keep a bit of history. But in this example, I'm just going to leave the names the same. Click OK. It then launches PCB Editor again. And you'll now see I've got R4 ready to place if I needed to. So we can bring R4 in as well. So let's just tidy up this placement. So I can go into placement edit mode, this little second green icon along here, and then it's single click items, and I can then start to rotate parts and do what I need to do. So let's just rotate the decoupling capacitor. We'll bring R4 up here. Let's put the resistors right next to the IC. And you can see if I place the components too close to one another, I'm going to get a DRC error, so maybe I need to just space them out a little bit. Right, click rotate. So I'm happy with the placement of my component. Oh, did I bring in R4? I did. Let's bring in R4. Right, done. Right. So the next thing I want to do now is I'm just going to set up some colours. So if we go to Setup and Colours, there's a corresponding little icon, these little 4 coloured squares. So obviously you can just click on the icon if you want. And it brings up my default colour boxes. So these are all the layers in my design. So I've got a stack up folder, areas, geometry. So stack up. I want my top of the board, so I can use this all checkbox to change all the colours in one go. I want that for the bottom of my board. I want that for my DRC errors. So you can see that's making an instant change in the canvas. I'm going to go to the Components tab, and I'm just going to turn off some of this text. So we'll turn off all the text, and I'm just going to turn on the silkscreen top layer. I'm going to make that white. So that then gives me the silk screen. If we go to the geometry layers, I'm going to turn off the assembly top, and I'm going to look for silk screen top. So there's my silk screen top. I'm going to make that white as well. And then I also want to do the design outline. I'm going to make the design outline white to start to see what's going on. So that's some default colour operations. Obviously you can set the colours that you need. So the next thing I want to do is maybe start doing some routing, but before I want to do that, I want to set up some rules. So if we go to Constraint Manager, it's where all the rules are set. Set up constraints. Again, corresponding icon, CM, the little CM icon up here. This is where all the rules are defined. So we have lots of different tabs, much like an Excel workbook. I've got a physical domain, so I can look at effectively all the nets in my design. Hit this little plus and you'll see the list of the nets in my design. And I have a rule set area, so I have a default rule set. Now obviously, with the quantity of nets here, I could literally just come along in here, make a change, so my min line width for these values would be 0.5 for example. But I'm making overrides on these nets. This is kind of quite in a design this size, it's probably not too bad because we've got what, maybe less than 10 nets. But in the design, if you've got a much larger design, you might want to start manage this a little bit better using kind of the rule sets and applying rule sets to nets and net classes. So what we'll do here is we'll just clear that. If we go back to the physical constraints at all layers, instead of me overriding, what I'm going to do is I'm going to say my default rule needs to be, say, let's make it 0.3 for example. So come back to the nets, that's actually made that change to the default rule. Let's go and make a new rule. So we can right click, create something called a physical C set. I'm going to call this power. The power rule, I'm going to set it to maybe 0.6. So I've now got a 0.6 thick track, or 0.6 millimeter thick track. So then I go to the all layers and I can say, instead of the -5, the ground and the VCC using the default rule, what they're actually going to use is the power rule, and you can see that it then changes those values. To take it one stage further, what I can do is I can actually start to make classes. So I can use the control click to pick the 3 nets that I'm interested in, right click, create something called a class. I'm going to call this power. And you can see it starts to group the nets, and then I can then apply my rule set to that net class. So you can start to kind of be very specific about how you do your nets. Let's go back and let's make another rule called diff pair. So we'll create something called a physical C set. And my diff rule, effectively I want it to be let's do 0.2. We can just tab across between these cells. My min-line spacing, let's set the primary gap first, so I want to 0.2 as the primary gap. I'm going to put a tolerance on it of 0.05, positive and negative, and then I have a value here, min-line spacing, which is effectively the primary gap minus the tolerance. So in this example, 0.15. So I've now effectively defined a differential pair rule. I'm also going to define some vias. These are the default vias that Cadence give you. There's one called via. If you actually click in the cell here, you then get a list of all your pads in your pad path. There's lots of videos about how to do this kind of stuff. And you can see anything using a filter. And we just get rid of the filter. You'll see all the pads in your pad path. I'm just going to start to type something like via. We'll get rid of this one, and I'm going to use a via 0.5 for this rule. I'm going to do that for all the rules actually, so we'll just get rid of that one. And we'll get rid of the default via and use this one. I've now got some vias I can use. There are videos on how to create vias and pad stacks if you look on the Parallel Systems YouTube channel, Parsis EDA. So once my rule set is defined, I'm going to go to the net or layers. I want to make a differential pair, so I can literally just drag select these two nets, right click, create differential pair. I'm going to call it DP underscore, and we'll create, and I now have effectively a differential pair called in, and then I'm going to apply my differential pair rule to there. So I now have rule sets here. Let's go to the spacing tab. We'll look at spacing or layers. Everything's set to 0.127. I want to change that, so if I literally just left click the default, I can then set a value. Let's set that to 0.2. So I've now got 0.2 of a millimetre as a rule set between all of these. Lots and lots of other rules. There are videos on Constraint Manager, so it's worthwhile having a look at that. The final thing I'm going to do is go to the differential pair. For my differential pair, I'm going to change the gather control to ignore. I'm going to set a max uncoupled length of 1 millimetre, and I'm going to set a static phase tolerance of 0.5 of a millimetre. Now you'll see some of these columns are yellow, which means that the rule sets aren't enabled. So if we go to Analyze and Analysis mode, I can look at my rule sets here. So obviously I want to turn on my differential pair checks in standard base license. Obviously physical, most of the physical ones are on by default. Spacing, they're all on by default for you. So you can you can make a decision about which rule sets you need. But it's worthwhile having a look at the constraint modes just to decide what you need to do from a rule set point of view. Okay, so once our rules are all ready, we can actually start looking at routing the board. So what we'll do is we'll close Constraint Manager, and then we can either invoke the root connect command, so root connect. We can press the F3 button. We can use this little icon here, so this corresponding icon here. And then we'll see an options pane that gives us our default kind of active and alternative layer, what line style, etc. So we click on a pin effectively, so let's just click on a pin and we'll start to route. And you can see that this is obviously the ground connection. It's using the default line width for the power. And we can kind of come on, make a connection, make a click to join the routing and start routing this way. So very, very quickly you can see I use this one. It uses a thinner track, which is the 0.3 thick track. And we can come down, just come out something like that, and route down to the bottom. And then we'll take it from this segment. So we'll just go ahead and route the board as we need to. So just as for your information, if you're routing along and you wanted to change layer on this design, I can actually do it all single-sided, but we will actually just show you how to change layer. So you can come up. Let's just say I wanted to go to the alternative layer. Literally, I can just double-click and add a via, and you can now see that the active and alternative layer swap over. If you had more than one layer, you can obviously come up here and change these from here. We can also change the active and alternative layers from a right-click, so you can see these options here. And that's just a quick and easy way to route. There are other methods of routing. There's something called working layer, which when you start to do multi-layer boards can be a lot easier and a lot quicker because it actually gives you a pop-up directly by your mouse so you can choose which layer you want to go to. And you can work your way around and go and route the board. So double click to add a via and it would swap the active and alternative layer, and then I can make a left click to finish. And then finally, from a routing point of view, when I click on one of these pins, obviously this is the differential pair that we defined. Both traces jump together, so you can see I effectively get based on the rules that we specified, and I can just route around. So let's come in something like this, and then I can go and finish the traces. And and that routes the differential pair. Now obviously I'm getting a DRC error here, so if I just hover over the DRC error, I've got a phase tolerance issue. So you can see that the constraint value we set for static phase, so that they must be in tolerance of 0.5 millimeter of one another. They're actually out by 0.0628 of a millimeter. So I might be able to get that resolved by literally just using the slide command and trying to kind of reduce the corners here. But more than likely I won't be able to kind of get that DRC resolved, so what I'll probably have to do is add a small segment. So for this example, I'm just going to change editor. I'm going to go to a professional based license, and then there's a command called root, and I can either use the phase tune command or the delay tune command. The phase tune command will effectively allow me to add a bump of a certain size. So this one, if I just added a phase bump based on that size there, you can see that my DRC disappears. It's added a small phase bump because the lengths are now matching. And to confirm this, we can go to Constraint Manager, and if we look at electrical and differential pairs, you can see, let's just analyse this, you can see that they're now within tolerance by 0.02 of a millimeter, so they're less than 0.5 millimeter, hence the reason the constraint has gone green. So the next thing I'm going to potentially look at doing is adding some copper planes here. So what we're going to do is I'm going to delete the ground track. And then what I'm going to do is I'm just going to add a couple of fan out vias here. So what we'll do is let's use the fan out command. So root create fan outs. I can just make the fan out, let's just make it go outwards based on the defaults, and I click on the find filter and just have pins. So I'm going to have that one coming out there, that one coming out there. In fact, let's just do, oops, let's change the options to pin to go southwards. So I've now got a couple of vias here and a pin here. So I'm going to draw a shape, so literally I can use the shape polygon. I'm going to pick the layer as being etch and bottom. I want it to be associated to the ground net, so I hit the double dot here and pick the ground as the net, click OK, and then I can go and draw the plane that I want. So my ground plane just needs to cover this area here. And when I complete this track, you can see obviously the vias get connected, all the connections are consumed, and I get a thermal relief connection to the pin. And you can repeat that. There are other commands, so we can use a Z copy command, for example. So if I did the shape Z copy, what I'm going to do is I'm going to copy it to the bottom layer. I'm going to create a dynamic shape. I'm going to contract my board outline by 1 millimeter, and I'm going to left click on my board outline. So that gives me the shape, and then I can use the shape, select shape or void, pick the shape, and then I can pick the net again. So we'll come along and make this one VCC, click OK, and you can see that effectively that net gets consumed. So we could then, effectively, we don't need to route this trace, because obviously we've got a via making connection there, and we don't need to that one there, that's got the thermal relief, so we can actually get rid of the via there as well. So and worst comes to the worst, what we could do is always slide this via down, which tidies it up, so we've now got a VCC plane and a ground plane.